Before we start the podcast, we wanted to let you know about WestOS. If you're a teacher or pupil at a school in Scotland, then you now have access to hundreds of quality assured video lessons created by teachers to support your remote learning. You should be able to find WestOS within the app library of Glow, where you can add the tile to your own personal launchpad. Click on the tile and you'll have immediate access to stream lessons in every area of the Scottish curriculum, with video lessons already available for biology at National 5, Higher and Advanced Higher. Now let's get on with the podcast. This podcast is sponsored by Lecky textbooks, revision guides and practice papers, everything you need to learn, review and prepare for your senior phase assessments. Browse the books at www.leckyscotland.co.uk and get 40% off using the discount code LeckyPodcast40. We're thrilled by the overwhelming support for our episodes featuring top-notch experts delving into various biological realms. Thanks to the feedback from higher biology students, we're launching shorter, punchy revision episodes. Get ready for quick summaries of key areas to turbocharge your exam prep. These short episodes can support your exam preparation and are not intended to replace other important aspects of your revision. In this episode, we're diving into metabolism and adverse conditions, a key area of the course that looks at how organisms deal with environments that push their metabolic limits. We'll explore how some animals survive challenging conditions through dormancy, like hibernation, estivation and daily torpor, and how others choose to avoid the problem altogether through migration. From land snails sealing themselves off in the summer heat, to birds entering torpor at night, and monarch butterflies flying thousands of miles every year, we'll break down the strategies that allow life to persist even when the environment turns hostile. Many environments vary beyond tolerable limits for normal metabolic activity for any particular organism. Now, some animals have adapted to survive these adverse conditions while others avoid them altogether. Dormancy is a part of some organisms' life cycle to allow survival during a period of adverse environmental conditions, when the costs of maintaining normal metabolic activity would simply be too high. Metabolic rate is reduced during dormancy in order to save energy. Now, dormancy can either be predictive or consequential. Predictive dormancy occurs before the onset of adverse conditions, while consequential dormancy occurs after the arrival of the adverse conditions. Now, the advantage of consequential dormancy is that the organism can remain active for longer and make use of available resources, while the disadvantage of consequential dormancy is that a sudden and severe change in environmental conditions can kill many of the organisms before they've even had time to become dormant. Now, hibernation in animals can be consequential dormancy, and it's defined as a period of dormancy which involves reduced metabolic rate to survive winter conditions. Now, many animals stock up on extra food to lay down a store of fat before they enter a period of dormancy, and during hibernation, mammals reduce their metabolic rate by slowing down their breathing rate and their heart rate to become inactive. Now, the European hedgehog, which is common across the UK and will be a familiar species to many of us in Scotland, is a classic example of an animal that enters a predictive hibernation. As the days shorten and the temperatures drop, they prepare by storing fat and then becoming inactive for the winter months, hibernating in nests that they've made from leaves and grass. And during this period, they drastically reduce the heart rate from as much as 190 beats per minute to as low as 20 beats per minute. Now, estivation is another common example of consequential dormancy, but it's a defined period of dormancy by some animals to survive periods of excessive heat and drought in summer, so quite different from hibernation. An example of estivation might be a land snail retreating into their shell, sealing themselves off with a layer of mucus and leaving a tiny little hole to allow for gas exchange. It basically prevents them from drying out in extreme heat. Other examples include tortoises, lungfish and crocodiles, which reduce their metabolic rates when they enter a period of estivation. As well as hibernation and estivation, we also look at daily torpor. Now, daily torpor is a defined period of reduced activity in organisms with high metabolic rates, and it involves the animal's rate of metabolism and activity being reduced for part of every 24-hour cycle. It's quite common in birds and small animals, and a good example might be a hummingbird, which has got extremely high daytime metabolic rates and then enters daily torpor every night in order to conserve energy. Now, while some animals choose to survive adverse conditions through strategies like hibernation and estivation, others use migration to simply avoid metabolic adversity altogether by expending energy to relocate to a more suitable environment. And we use specialised techniques to monitor these long-distance migrations, such as satellite tracking and leg rings. Migratory behaviour can be a combination of both innate and learned influences. Now, innate behaviour is inherited and inflexible, while learned behaviour is flexible and occurs as a result of trial and error and passing down of knowledge and skill amongst members of a social group. An example of migration which involves innate behaviour is the monarch butterfly. And every autumn, millions of these monarch butterflies migrate 3,000 miles from their breeding grounds in Northeast America to spend the winter in the forests of southwest Mexico. The amazing thing is that each migration is by a new generation. So there's no way that the butterflies can learn from others. Instead, the monarch butterfly migration is innate and determined by their genes. And closer to home, Atlantic salmon migrate from the ocean back to the Scottish rivers where they hatched. It involves both instinctive navigation and environmental cues, and shows how learned and innate behaviours can work together. You can learn more about Atlantic salmon and how they migrate and move between saltwater and freshwater in our extended episode on Conformers and Regulators with Professor Ken Whelan. So hit subscribe on whatever platform you get your podcasts so you don't miss the rest of our short summary episodes nor our regular episodes with leading experts. And remember, this quick summary is intended as just one element of your broader revision plan. There are lots of resources available via Glow such as Scholar or West OS, as well as BBC Bitesize. Or why not check out one of Lecky's great revision books and use the code LeckyPodcast40 to get 40% off on their website www.leckyscotland.co.uk.